Okay, thank you for joining all of you. So today we are going to discuss the some introduction about the microprocessor and how the microprocessor revolution has happened in the past years. Okay, uh, remember this is also one question. Last day they can ask that the evolution of microprocessor and write the some features of the microprocessor. And, some papers they can ask that the 2 marks question. Some papers they can ask that the some 5 marks and 7 marks also. Okay, so very simple that one. Then you just see the what are the basic features of the microprocessor and some what is the microprocessor and what is the evolution of the microprocessor. Okay, now see this once again some images of the microprocessor. You know that this is our microprocessor 8086 microprocessor. Okay, this is our 8086 microprocessor. Look like this. You know that these we can call it as the pins. These we can call it as the pins. Here, see this. These are the pins. These are the pins. Pins. These we can call it as the pins. Here, see this. These are the pins. We can call it as a pin. Okay. Now this one you can call it as the pins. Here our 8085 microprocessor has 40 pins. Again, this one is also 40. These are different configurations are there. 18 pin microprocessor, 18 pin are there, as well as some 32 pin are there. Different types of pins are there in PIC8 microcontroller. This 805 microcontroller has 40 pins. At the same time, 8086 microprocessor has 40 pins. You should remember one thing here. The more the pins, more the pins. Remember, more the pins. It has a more the cost. More cost. At the same time, more powerful. Remember this one very carefully. Okay, if our device has more number of pins, it has more cost. At the same time, it has more power. I tell you why this is why it has more cost and why it has more powerful. In the coming lectures we will see this. You will definitely see this. Why it is more powerful when our microprocessor is 40 pin microprocessor. We have more number of pins on the microprocessor, so microprocessors work very efficiently. So if you increase the number of pins, the performance of the microprocessor is also increased. But this our microprocessor, our Intel developed microprocessor, has only 40 pins. Okay, so these are some basic images of the microprocessor. Is look like this. So you see this the shape of that microprocessor as well as microcontroller is similar. Remember, you see this? It is look like similar. See this similar, but internally the devices that is arranged is different. That you can call it as the architecture. The architecture is different from microprocessor to the microcontroller. The architecture is different. Okay, so how this architecture is happened in the system. Okay, so we'll in the coming classes we will definitely see this architecture of the microprocessor as well as architecture of this microcontroller 8051 and at the same time architecture of the PIC18 controller. Okay, before going to that one, we will see this some difference between the microprocessor and microcontrollers. What is the difference between microprocessor and microcontrollers? So microprocessors are very much used for the big applications, but it is microcontroller is used for the single task applications. As I said, because the cost of the microprocessor is around 3 to 5,000 and above. That, but the microcontroller cost is nowadays is around 100 rupees is also there available there. So because hardware is very costly, this hardware is somewhat low. So it is not easy to replaceable, but it is easy to replaceable because of so many factors. Main thing is cost. So it is the power consumption is also very high because of the a powerful machine. Microprocessor is powerful when compared with the microcontroller. So that's why power consumption is also very high. So this is developed on the CMOS technology because this advantages of CMOS technologies, it can consumes the less power, less power. So CMOS technology means here, so you can develop the transistors. You know that in the early days we are using the some vacuum tubes. You know that vacuum tube. You know that in the early days vacuum tube cost one vacuum tube nothing but one transistor cost is around 65K in the early days. Nowadays the transistor is available in the 20-30 rupees also. Vacuum. Then come to the solid state technology. Then the next technology is solid state technology. The next one is CMOS technology. These are the technologies used to develop the transistors and diodes. Now nowadays there are so many people are using this CMOS technology. Cool. Okay. Now it doesn't contain any RAM, ROM, and input output ports. These are the memories. These are the memory. RAM and ROM are the memory. I can call it as the primary memory. I can call it as a primary memory. So it consists of a CPU, RAM, ROM, and I/O ports at the same IC. So that's why a microcontroller is a computer on a chip. So, but this microprocessor as doesn't have the input output ports. I mean, as well as RAM and ROM in the same chip. So that's why only it has the CPU. That's why we got as a CPU on a chip. Okay. Now see the some basic structure of the microprocessor or computer, some small. Yeah. Input devices, output devices. Okay. Input output ports, a CPU, a memory. These are the some control buses, some data buses as well as some address buses. I tell you each and every component in detail. Okay, you don't worry about that one. What are the different types of input devices? What are different types of output devices? What are the input output ports? Then what is the control bus? What is the data bus? What is the address bus? What is it? Okay, this is the some black diagram of some a small computer, a small computer. Okay, a microcontroller, it has the all the things in built in a single chip. A single chip is all the things. Okay, so this is we can call it as a computer. Remember, this is you can call it as a computer. It has a CPU and all, but this is our microprocessor. This is our microprocessor. So whenever microprocessor is running successfully, it works. So you require all the things: input and output devices, I/O ports, and control bus, and memory, data, and address. Whenever so microprocessor is working, nothing but efficiently, you require all these things. Okay, so I can simplify this diagram into this way. You can see this. You can see this. This is the some basic structure of the microprocessor. Remember, this is the basic structure of the microprocessor. This is the CPU. Remember, this is the CPU. Okay, now see this. So yes, this one. You can see this entire thing. I will draw this way. I will remodify the diagram to this one. So the basic structure of the microprocessor. See this. This is the CPU. This is the CPU. So in the CPU, you know that in the computer, you know that CPU is this. What is the CPU? Central Processing Unit. Central Processing Unit. In the CPU, it has ALU. What is the meaning of ALU? Arithmetic and what is the meaning of ALU? Arithmetic and logic unit. Logical unit. Arithmetic and logical. What are the arithmetic operations? What are the arithmetic operations? Additions, subtractions, multiplications, and divisions. What are the logical operations? What are the logical operations? AND operation, OR operation, NOT operation. These are some basic operations. We have some XNOR operation, NAND operation, some different logical operations. These are the basic AND, OR, and NOT operations. Then these are what are the arithmetic operations? Addition, subtraction, multiplication, and division. So what are the registers? What are the registers? So registers is also the some type of memory devices. So in the STLD or some logical devices chapter, you already learned the flip-flops. Yeah, flip-flops. These flip-flops, by using these flip-flops, you can manufacture it or you can design these registers. Some this registers is like this. Yes, 4-bit register or 8-bit register. Okay, these are the flip-flops. So flip-flop 1, flip-flop 2, flip-flop 3, then flip-flop 4 like this. So each flip-flop, nothing but by using these flip-flops, you can design these registers. Okay, so this registers is different sizes. Remember, a 4-bit register, 8-bit register, multiple of 2, 8-bit register, a 16-bit register, 32-bit registers, then a 64-bit registers, and so on. Remember, whenever nowadays we are talking about Windows 10 and all, someone asks that, so which bit Windows it is. So you tell that 30-bit or 64-bit Windows. This is not the Windows, that is, so that is entirely depends upon the registers. Okay, that is register, 32-bit registers, 64-bit registers, 16 register, 16-bit register, 8-bit register, and 4-bit registers. Okay, so in the properties also, whenever we go for the properties, they can show that in a Windows 32-bit Windows and 64-bit, you observe that. So so whenever you see this properties of the Windows, nothing but our computer, properties of the computer in the real time, you should observe this one, 32-bit as well as 64-bit. Observe this one. This will indicate the these registers. This registers. Whenever you want to increase this register size, whenever you want to increase this register size, the performance of the microprocessor is also increases. Okay, so unfortunately, our 8086 microprocessor has the 16-bit microprocessor. 8086. When compared to the 16-bit, 32-bit microprocessor is working somewhat speed when compared to the 64. I mean, when compared to the 16-bit, 32-bit when compared to 64-bit is more fast. So the size of the registers is increases. The speed is also increases. Okay, then what is this one? Timing and control unit, a very important one. Timing and control unit. This we can call it as the timing and control. This timing and control unit, we have the some clock. You know that clock. You heard that clock. Whenever you want to buy the any microprocessor, you see that 3.2 gigahertz or 2.0 gigahertz. In the micro computer properties, you observe this one. So 2.0, 2.4 gigahertz. In your cell phones also nowadays we are using 3.2 gigahertz processor. Okay, quad core processor, then octa core processor. You heard that one names processor. Octa core. Octa means that 8. Quad means here 4 core processor. Octa core processor. 2.4 gigahertz, 3.2 gigahertz. Okay, 2 gigahertz. You heard that name. This will indicates the clock speed. If you increase the speed of this clock, the performance or the speed of the microprocessor is also increased. Remember, I said what are the different factors to improve the speed of the microprocessor. You know that. So 2 gigahertz microprocessor is very much slower when compared to the 3.2 gigahertz microprocessor. This will the speed is mainly depends on the clock. Remember, if you increase the clock, the speed is increased. Remember. So the first preference is given to the speed, then second preference is given to the registers. When you increase the speed of the microprocessor, first preference is given to the clock. Whenever you want to increase the clock speed, so the speed of the microprocessor is also increases. So what is this clock? Clock you can use it as a quartz, a crystal, oscillator. A clock we are using the device is a quartz crystal oscillator, or simply oscillator device. Simply a oscillator device. For the clock purpose, you are using some oscillator device. So remember, this timing and control unit is like a heart. Okay, heart of the computer. A CPU nothing but CPU nothing but ALU as well as registers. You can call it as the some memory. It's nothing but some memory device. It's nothing but some intelligence devices. These two. Or nothing but you can also call it as a brain of the computer. You know that brain. Okay, these two ALU and registers you can call it as a brain. In human, we can observe in human like our human structure. So this is the art of the art of the computer, a microprocessor or nothing else. So this timing and control unit is connected to the each and every devices that are connected within that CPU at the same time outside the CPU. Outside the CPU, like this device is also. Remember, okay. Remember this timing and control unit is connected to the each and every component that is present within the CPU, nothing but ALU as well as registers. At the same time, it is also connected to the outer side of the devices like memory as well as the input and output devices. Because this unit is control the everything. This unit is control the everything. Okay, uh, like our nerves, how the nerves is connected to the each and every part of our human body. Like this timing and control unit is connected to the each and every parts of the microprocessor as well as outside of the devices, and it can control the devices also. It can control the devices. It's like how that device is controlled by pumping the number of clocks, by pumping the clock. How our heart is pumping blood to activate the devices. A blood, some signals are blood to activate the devices. So likewise, uh, this timing and control unit is send some signals to activate the other devices. Whenever you are sending the signals to the each and every devices, it has some connections. Okay, it has some connections. So that's why this timing and control unit is connected to the each and every uh, part of the CPU. At the same time, outer world is also not outside it. Okay, now what is this interfacing? Now what is this interfacing? So interfacing, it has nothing but a pins. It has a pins. Interfacing is nothing but the pins. By using these pins, so you are connected the, as I said, this is a microprocessor. Microprocessor is nothing but this one. Microprocessor is only the CPU. This is the microprocessor. As I said, microprocessor has no memory as well as input output devices. So this is a microprocessor. So whenever microprocessor is working efficiently, you want to require the memory as well as the input output devices also. So how this input output device is connected by using this interfacing unit. You can call it as interfacing unit is nothing but the pins. As you already see, what are the pins? So these are this you can call it as a bus is nothing but a number of weights. Number of weights you can call it as a bus. Number of weights. So bus, we have some different types of buses is there. Control bus, data bus, address bus. We have different types of buses are there. So as you see this, the directions of the arrows. Remember, you can see these directions of the arrows. This directions of the arrows is also important. So whenever So see these directions. So nothing but that the communication is in between the CPU to the this outer side devices. At the same time, the communication. So in between the both side communication is possible. Remember, both side communication is possible. Both side. Okay, microprocessor is so now see this. Both side communication is possible now by using this buses. Buses is nothing but a number of words. So different buses are there. So control bus, data bus, as well as the address bus. Okay, then what is this devices? What are these devices? This memory we can call, we can again divide into the primary. Again divide into the primary. Then the second one is the second. Okay, remember, memory again you can divide into the primary as well as the secondary. Now see this. What is this primary memory? In the primary, so we have this is the so in the microprocessor we are using the primary memory. Primary, this memory you can call it as the RAM and ROM. Microprocessor is using random access memory, read-only memory. Random access memory as well as the read-only. We are using primary memory. So what are the some input output devices? What are the some input output devices? You know that some keyboards, keyboard, mouse, some monitor, all the things we are considering it as a input output device. How this input output devices are connected by using this pins. Pins by using these pins. So by using these pins, we are connected to this input output devices. Nothing but we can call it as this section. We can call it as interfacing section. But in our third chapter, so in our third chapter, you already see this syllabus. In the syllabus you already see this, and peripheral interfacing device. You know that you see this some devices. So interfacing devices, interfacing devices. In the third chapter, so in the syllabus we have the third chapter is also there. The third chapter we can call it as the interfacing devices. You have different types of interfacing devices are there. 8255. Remember that 8255, 8279. Okay, so 8259. Different types of interfacing devices are there. What is this interfacing devices? Why you are using this interfacing devices? One thing, the answer for one answer is why you are using interfacing devices means to reduce burden of the microprocessor, to reduce burden of the microprocessor. So connectivity issues, connectivity problems. Okay, then at the same time to match the speed, to match the speed. Remember these words very carefully. You can note down this one. So all the things you can note down. You take the textbook, you take the notebook and note down all the things what I am telling. Okay. So to reduce the burden of the microprocessor, why you are using interfacing devices? So you have different types of interfacing devices. The third chapter entirely dedicated to this. So in between the CPU as well as the in between the CPU as well as the this devices, we have the some here like this only. This way only you are connecting the here in between this CPU as well as input this outer side device memory as well as input output device. We have the this interfacing devices. The reason for developing this interface device is to reduce the burden of the microprocessor, uh, to avoid the complexity, at the same time to avoid the connectivity problem, at the same time to match the speed of the microprocessor, this microprocessor. Okay, at the same time this input output device. What is the what is this speed and all? You know that microprocessor is working the speed of a for suppose you can assume that microprocessor is working the speed of a 3.2 gigahertz. But our memory as well as input output devices speed is not matching to that speed 3.2 gigahertz. It is also some input output devices is also some internal memory. These devices are some internal. This speed is not matching. For suppose we have the printer. Printer is also the uh, uh, I mean nothing but some clock is also there in the printer also. Some speed, so the speed is mismatching is happen. Speed mismatching is happen. The best example for this one is, for suppose we have the some USB port nowadays. You know that some USB port. USB nowadays we have some 2.0 and 3.0. You know that 2.0 and 3.0 USB. USB nothing but universal port. Okay, so the device, that USB port you are connected to this some interfacing devices. You can call it as a USART. 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 You can call it as the device is USART. Universal synchronous asynchronous receive and transmit. USART. You can call it as a USART. Universal synchronous asynchronous receive and transmit. Universal. Nothing but whenever you go in the universe, the ports are similar. So that way they can develop the devices. Universal synchronous asynchronous receive and transmit. You know that in the USB pen drive, for suppose you can call it as a pen drive, and input device is pen drive. You can transfer the information from the computer CPU to the pen drive, or at the same time from the USB to the computer, whatever. A two-way transmission is happening. But you know that the speed matching, the speed mismatching is there. Whenever you are sending some data to the some USB, it takes some time. It takes some time. At the same time, whenever you copy the information from the USB to the microprocessor, it takes some time. It takes some time. Okay, why it will take some time? Because the devices is the device speed, nothing but the USB, the pen drive speed is not matching the, okay, this CPU speed at the same. So how this device is connected? So this device is connected in this connectivity problem. You can see this connectivity problem. How you are not connecting these devices to the directly. So there are some connectivity as well as some complexity issues is happen. So to reduce that one, we are using this input or nothing but this interfacing devices. To reduce the burden of the microprocessor means, what is the burden of the microprocessor? Huh? So you remember, microprocessor is working a multitask at a time, multiple tasks. For suppose you are copying the information from the pen drive, or you can send the information to the pen drive. Microprocessor is not only working that information. So for suppose I have the computer here, I am using the computer. So we can do some work, some PPT and all other things. At the same time I listen the songs and I see the movies at the same time. Multiple tasks at that time. Not only stick to the one operation. So microprocessor is performing different operations at a time. Multiple tasks you can do. So on that time, so for suppose you can open the 20 to 50 tabs, some Google tabs and some nothing but the some Google tabs, or you can on the some so 5 to 6 type of softwares at the time. What will happen? The speed of that microprocessor reduces. I think you are experiencing very well. You know that, or in our cell phones also you are experiencing. Whenever we are connecting some USB port to that cell phones, and the speed of that cell phone is reduces. So that happened. So that burden you are going to reduces by using this by connecting this interface devices also. So on that third unit, whenever you are come to the third unit, so we'll thoroughly and in deeply we are discussing. So this is the some basic structure of the microprocessor. It is like this. So there are CPU and all other things. Okay. Okay. You see this. Okay. This is the our. You are going to study all the things in our syllabus. We are going to study this. This we are connecting the interface devices. Interface devices. Okay, so in the coming lectures we are going to discuss all the things in depth, in deep. So what is memory, what is primary memory, the secondary memory, how the memory organization is there in the system. So what is input output device, what is ALU, what is registers, what is timing and control unit, what is interfacing unit, what are the, so this is dedicated to third unit, entirely third unit. Okay, going for the next slide. So what are some different types of input devices? So you can see very quickly input devices. You know that keyboard is one of the input devices. Then pointing devices is nothing but some mouses, some light pen is nothing but laser pointers, some touch screen. You know that some cell phones touch screens, and some laptops and systems touch screens, some remote control unit. You know that. So these are coming to the pointing devices. So these are nothing but these all are the input devices. Some so data, speech. You know, so nowadays a speech is a speech application, or speech. So one of the famous for Google Speech and all other things, Alexa and Google, Amazon Alexa and all other things. You know that this is also input commands to that any of the microprocessor. Then what are the some memory? You have, you know that memory you can divide into the two different types of memories: primary memory as well as the secondary. Primary as well as the secondary. Two different types of memories. Memories are there. So what are the primary memories? Read-only memory, random access memory, ROM as well as the RAM. At the same time, cache memory. At the same time, registers. Cache memory as well as the registers. Okay, read-only memory, random access memory, cache memory, as well as the registers. Okay, these are the primary memory. Then what are the secondary memories? As secondary memories, we have different types of secondary memories. Magnetic tape. You know that magnetic tape? You know that what is the magnetic tape technology? This is nothing but in the earlier days in the 2000 year and 2006. I mean, you are also see the cassettes. Cassettes, you have some magnetic film. A film is there, a film, so that you can call it as magnetic tape that has information. You know that cassettes and some albums, some marriage albums in cassettes, or songs in the earlier days, they can use that cassettes. So that has some film is there, that is the magnetic film. So nothing but in our ATM cards and debit card, credit cards, and ATM cards we are using. In the back side, you have some, you can adjust some black strip, a black strip, that is a magnetic tape that has your total information. So that has your total information. So that is also one type of memory, a magnetic tape. So then second one is the magnetic disk. Magnetic disk. Second technology, second memory technology is magnetic disk. A second memory technology is magnetic disk. A magnetic disk is hard disk. Now we are using this technology. Hard disk, again you have different types of hard disk is there. SATA type of memory as well as SSD. Solid state technology devices. SSD. SSD is more speed when compared to this one. This floppies, you see that floppies is look like this, a floppy, a very small memory, 32 MB floppies, and 64 MB floppies, and 128 MB floppies is also there. I also see the floppies in my age. I also see this floppies. Nowadays there is no, you can see this nowadays the laptops and all other things. There is no CD-ROMs. You know that series. You are already aware of that series. Then USB is now we can add the USB also. You can add the USB also nowadays. These are secondary memories. You observe that one. What is the primary memory? What is the secondary memory? What is the difference between this? What is the difference between this? So what is the difference between this? You observe this one. So primary memory as well as the secondary memories. So primary memories, you see this RAM and ROM as well as cache as well as registers. Registers is available in the CPU. Okay, these are available in the outside, but these all are present in the CPU on a chip. The chip is one chip, one chip. So by using some interfacing, you are connected to the RAM and the ROM to this device. Then what is the secondary device? Secondary memory. So secondary memory, you know that nowadays you are buying the any a cell phone and all other things. You see that 4 GB RAM or 8 GB RAM, 128 GB hard disk, or 128 GB cell phone, or in the computers you can see this 8 GB RAM and 1 TB hard disk, or 500 GB hard disk, or 128 GB SSD memory. You see this? You already heard that one. Those are the 128 GB or some is like this 500 GB hard disk or 1 terabyte hard disk. All are the secondary type of the memories. Secondary type of the memories. Okay, so these are the primary type of the memories. Okay, these are the second type. So what are the some output images we have? What are some different types of output images? Some monitors, the printers, you know, some scanners, printers, some microfilms, you can call it as the some output images. Okay, so now see this the differences between this primary as well as this secondary memory. You can go once again. I will tell you what is cache memory, what is the memory organization, how the microprocessor is connecting these memories and other things. I will tell you. Now see this. This we can call it as a memory pyramid. Remember, these are not available in the textbooks. Memory pyramid or memory hierarchy. You can call it as a memory hierarchy. Yes, memory hierarchies. So these are the registers. Okay, these are the registers. So these are the primary memory. These are the secondary memory. These are the outer side. Nothing but some external hard disk, external devices. These are hierarchy. You can see this hierarchy. So microprocessor is first connect the registered memory. Remember, microprocessor is first connect the primary. So first connect the registers memory, then next connect the primary memory, then next given the preference to the secondary, and then next connect the fourth is nothing but the fourth. Again, you can see the memory size. Whenever it goes down, the size of the memory is increases. So secondary memory is more when compared to the primary memory. Register memory is more when compared to the primary. Okay, primary memory is sorry, I was taking. Register memory is very less when compared to the primary memory. So what are the primary devices? RAM. You see this. These are the primary devices. RAM, ROM. Okay. Then what is the secondary memories here? We are talking about the hard disk here. An hierarchy, memory hierarchy. Then secondary USBs, some CDs we are connecting like this. Microprocessor is able to connect the first registers and then primary memory and then secondary memory. So in between this, see this. Okay, in between this registers and the primary memory, we have some cache memory. Cache. Okay, cache memory. So now see this. We have another type of the one memory is also there, a flash memory. Flash memory that is invented by the Toshiba, a flash memory. In the pen drives also, Toshiba pen drives, you can also observe the a flash memory first invented by the Toshiba, flash memory. In our present day, you are using cell phones 128 GB or 64 GB memory. We are using this flash memories. A flash memory is also nowadays. So these are the some memory hierarchy. Okay. So these are the series. Again, you can repeat this. We are already observed this one. The difference between microprocessor and microcontrollers. This is the CPU. So this is the microprocessor. Remember, this is our microprocessor. So I can redraw this entire structure into the like this. A CPU, arithmetic and logical unit, registers and timing controller. This is the interface unit. By using this interface unit only, you can connect the memory and input output devices. So what are the input output devices? So these are some different types of input devices, and these are some different types of the these are the input output devices. Some some different types of the memory. You have primary memory as well as secondary memory. Primary memory, these are the RAM, ROM, cache, and registers. And then secondary is magnetic tape and magnetic disk technology in zero. So magnetic disk, now we are using this in our laptops and cell phones and other things. So that's one. So then one type of another memory is also the flash memory. Okay, so then these are some different types of the output devices. So now coming class, for next class, we are going to discuss the evolution of the microprocessor. So what is the evolution here? So then how that then what is the number of bits of that microprocessor? Then what is the clock speed of that microprocessor? And, okay, in the coming lectures we'll see this. Thank you. Thank you for